Welcome to the Explainer. So, we are currently looking at an absolute avalanche of new, groundbreaking climate data that just dropped in mid 2026. Things are shifting incredibly fast, and today we're going to break down the latest science piece by piece. We'll look at what's actually driving these planetary shifts, how it's playing out on the ground, and of course, the brilliant innovations being designed to help us navigate it. Now, you might be wondering, what actually happens when the Earth's energy imbalance doubles? I know, it sounds kind of abstract, right? Almost like a purely theoretical physics problem. But the answer to this stark question literally dictates the weather outside your window, the food on your plate, and the stability of our entire global infrastructure. So let's look directly at the latest empirical science to find the answer. Here is our roadmap for today. First, a planet out of balance. Second, extremes on the front lines. Third, the disproportionate human toll. And fourth, science and inclusive solutions. Okay, let's dive into this. Section 1. A planet out of balance. Exploring the systemic catalysts. 1.37 degrees Celsius. That is a critical milestone, folks. Updated climate indicators confirm that human-caused global warming officially hit 1.37 degrees Celsius in 2025. And listen, this isn't some future projection. This is an established, real-world measurement. What this number tells us is that the Earth is accumulating heat at a record rate. We are edging remarkably close to that 1.5-degree threshold scientists have been warning us about for decades. This 1.37 degrees of warming is our foundation now. It's the new elevated baseline upon which all of our current global weather operates. What's really interesting about this is how things have shifted over time. In past decades, the Earth had a relatively stable energy balance. The energy entering our atmosphere from the sun roughly equaled the energy radiating back out into space. But present-day data shows this energy imbalance has actually doubled. Think of the Earth like a massive battery being overcharged. Because of greenhouse gases, less heat is escaping, creating these vast reserves of trapped heat that act as the exact engine driving our future warming. And on top of that new baseline, we have this. NASA's recent satellite observations have officially confirmed that a strong El Niño is currently underway. These satellites are actually measuring the sea surface heights in the tropical Pacific, which physically bulge as the water warms up. A strong El Niño acts as a massive systemic driver, shifting global weather and rainfall patterns all over the place. When you take a natural warming phenomenon like El Niño and layer it on top of a doubled energy imbalance and a 1.37-degree baseline, well, you get unprecedented systemic heat. Which brings us right to the front lines. Section 2, Extremes on the Front Lines. The physical manifestations of a warming world. Check out this quote. It comes directly from rapid attribution scientists who are analyzing the intense heat dome that settled over Europe. They concluded that Europe's late June heat wave would have been virtually impossible without human-caused climate change. Rapid attribution is this fascinating field where scientists use massive computational models to compare our current climate to a simulated climate without human emissions, and they found a definitive, undeniable link here. This wasn't just a bad summer, it was a scientifically proven manifestation of our shifting planetary baseline. And the cascading consequences of this heat wave were just staggering. Over 100 million Europeans were suddenly exposed to temperatures soaring past 35 degrees Celsius. Our infrastructure simply wasn't built for it. We saw major power outages rolling across France as electrical grids completely wilted under the pressure of cooling demands. The World Meteorological Organization reported record-shattering health impacts across the continent. And the severe scorching wasn't isolated. It blanketed the UK, France, and Spain. This is exactly what a doubled energy imbalance looks like when it crashes into human infrastructure. And this brilliantly illustrates the wider impact. Geographically pivoting to the Swiss Alps for a second, researchers report that the glaciers there have completely and permanently exhausted their protective snow reserves. Normally, winter snow acts as this reflective shield, protecting the darker, ancient glacial ice underneath. But with that snow gone, severe summer melt is totally guaranteed. We're losing deep reserves of ice that have stood for millennia, which fundamentally alters the alpine ecosystem and our future freshwater supplies. Section 3. The disproportionate human toll. The inclusivity gap in climate action. We need to talk about how extreme heat is heavily punishing remote First Nations communities. Because of geographic isolation, they face a really severe lack of specialized infrastructure and emergency services. Climate adaptation cannot just be these top-down policies dictated from a far-off capital city. We absolutely must urgently listen to local knowledge and the lived experience of these communities. They're on the absolute front lines of these new heat extremes, and their insights are vital for crafting survival and adaptation strategies that actually work in the real world. 1.3 billion. I want you to just anchor yourself on this massive number for a moment. This represents the global disabled population. That is 1.3 billion individuals who are currently and routinely being left out of critical climate planning. When a severe weather event hits, like those heat waves we just discussed, people with disabilities face exponentially higher risks. But there are solutions. Experts have identified clear, actionable ways we can immediately close this inclusive gap during climate emergencies. First up, accessible urban planning. We have to ensure evacuation routes and cooling centers are physically accessible to everyone. Second, inclusive early warning systems. Look, a siren doesn't help someone who is deaf, and a text alert might not reach everyone. We need multi-sensory inclusive alerts. And third, direct participation. We really need to stop planning for disabled people and start planning with them. Put them at the table for climate policy decisions.
Section 4, Science and Inclusive Solutions. Adaptation, innovation, and policy.
The good news is science isn't just watching the disaster unfold, it's actively decoding it. Researchers at Penn State have literally created artificial permafrost right inside a laboratory setting. By simulating thawing Arctic ground conditions indoors, they can measure exactly how much carbon and methane is released before a real-world collapse even happens. So the crucial point is, this gives policymakers incredibly precise data years in advance. Then there's our food supply. Systemic climate stress physically reduces the micronutrient density in staple crops. Basically, warmer climates make our food less nutritious. But against that massive problem, we have the incredible potential of CRISPR genetic technologies. Researchers are actively exploring how to edit plant genetics to restore and actually improve the nutritional profile of crops so they can thrive in our new 1.37-degree baseline. We are quite literally reprogramming our food to survive the future. But here's the catch. Technological innovation is practically useless without coordinated policy to back it up. Recent expert warnings highlight a really stark contrast. When we take a fragmented approach to environmental policy, efforts can actually work at cross purposes, resulting in ecosystem harm and wasted funds. Conversely, smarter, coordinated land use achieves a triple win. It protects biodiversity, advances our climate goals, and unlocks massive economic gains. Coordinated policy isn't just a nice-to-have for the Earth, it is economically essential. So what does this all mean? We've seen the undeniable metrics of a warming planet. We've seen the blistering reality on the ground in Europe and the Swiss Alps. We've recognized the immense vulnerability of marginalized groups, and we've explored the breathtaking ingenuity of things like artificial permafrost and CRISPR technologies. The bottom line is, we have the data. We have the tools. Surviving the 2026 climate crisis requires marrying our scientific ingenuity with deeply inclusive human action. The roadmap is entirely visible to us now. The only question left is, will we listen? Thanks so much for joining me on this explainer. Keep asking those big questions, and I'll see you next time.